Welcome to Intelligence Gateway.
Cybersecurity. Lecture 5.1. Antivirus and firewalls are two crucial components of a robust cybersecurity strategy. They work together to protect computer systems and networks from various threats. In this lesson we'll learn about 1. Antivirus software and detection techniques. 2. Software and hardware firewalls and the filtering techniques they use. 1. Antivirus software and detection techniques. Antivirus software, also known as anti-malware software, is designed to detect, prevent, and remove malicious software, malware, from computer systems. It employs various detection techniques to identify and mitigate different types of malware. Here are some common antivirus software and 1. Signature-based detection. This technique relies on a database of known malware signatures. Antivirus software compares the signatures of files or programs on a system with the signatures in its database. If a match is found, it identifies the file as malware and takes appropriate action, such as quarantine or removal. 2. Heuristic analysis. Antivirus software uses heuristic analysis to identify potentially malicious behavior or characteristics of unknown malware. It analyzes the code or behavior of files and programs to detect suspicious patterns that may indicate the presence of malware. Heuristics help identify new or previously unseen threats that have not yet been added to the signature database. 3. Behavior-based detection. This technique monitors the behavior of files, applications, or processes in real time. It looks for actions or activities that are indicative of malware, such as modifying system files, accessing sensitive areas, or attempting to propagate or infect other files or systems. Behavior-based detection helps identify malware that may be using advanced techniques to evade signature-based detection. 4. Machine learning and AI-based detection. Antivirus software may employ machine learning and artificial intelligence algorithms to analyze large volumes of data and identify patterns that indicate the presence of malware. These techniques can improve detection accuracy by learning from both known and unknown malware samples. 5. Cloud-based detection. Some antivirus solutions utilize cloud-based detection methods. When a file or program is scanned, it is compared against a database of known malware stored in the cloud. This approach enables real-time access to updated threat intelligence and reduces the reliance on local resources for detection. 6. Sandbox analysis. Antivirus software may use sandboxing, where suspicious files or programs are executed in a controlled virtual environment. This allows the antivirus software to observe their behavior and determine if they exhibit malicious actions. Sandbox analysis helps identify and analyze previously unknown or zero-day malware. 7. File reputation analysis. Antivirus software may leverage file reputation services to determine the trustworthiness of files based on their prevalence and behavior across a large user base. Files with a poor reputation may be flagged as potentially malicious. It's important to note that no single detection technique is foolproof, and antivirus software often employs a combination of these techniques to enhance its effectiveness. Regular updates to antivirus software are essential to keep the malware signature database up to date and maintain protection against evolving threats. Additionally, antivirus software may offer additional features such as real-time scanning, web protection, email scanning, firewall integration, and vulnerability assessment to provide comprehensive protection against malware and other cyber threats. 2. Firewalls and filtering techniques. Firewalls are network security devices that monitor and control incoming and outgoing network traffic based on predefined rules. They act as a barrier between an internal network and external networks, providing protection against unauthorized access and malicious network activities. Firewalls employ various filtering techniques to control network traffic. Here are some common firewall filtering techniques. 1. Packet filtering. packet filtering is the most basic form of firewall filtering. It examines individual network packets based on criteria such as source and destination IP addresses, ports, protocols, and packet headers. The firewall either allows or denies packets based on the defined rules. Packet filtering is typically performed at the network layer, layer 3, of the TCP/IP protocol stack. 2. Stateful inspection. Stateful inspection firewalls maintain a state table to track the state and context of network connections. They analyze not only individual packets but also the complete network session. By understanding the state of connections, stateful firewalls can make more informed decisions about whether to allow or block traffic. This technique provides better security against certain types of attacks, such as spoofing or session hijacking. 3. Application layer filtering. Application layer filtering, also known as deep packet inspection, DPI, operates at the application layer, layer 7, of the TCP/IP protocol stack. It inspects the content of packets beyond the packet headers to analyze the actual application-level data. This allows firewalls to identify and block specific applications or protocols, even if they are using non-standard or dynamic ports. Application layer filtering provides more granular control and enhanced security but can be resource-intensive. 4. Proxy servers. Some firewalls act as proxy servers, intermediating network connections between internal and external networks. When a client makes a request to access a resource, the proxy server acts on behalf of the client and retrieves the resource. It can analyze the incoming and outgoing traffic, filter and modify the data, and provide an additional layer of security by hiding internal network details. Proxy servers can be used for various protocols, such as HTTP, FTP, or SMTP. 5. Network Address Translation. NAT is a technique used by firewalls to translate private IP addresses to public IP addresses when communicating with external networks. It helps hide the internal network structure and provides an additional layer of security by masking internal IP addresses from external sources. 6. Virtual Private Network, VPN, filtering. Firewalls with VPN capabilities can apply filtering rules to encrypted VPN traffic. This allows for secure remote access to internal networks while ensuring that only authorized traffic is allowed through the VPN tunnel. Firewalls use a combination of these filtering techniques to enforce security policies and protect networks from unauthorized access, network-based attacks, and the transmission of malicious traffic. Proper configuration, regular updates, and monitoring of firewall rules and logs are crucial to maintaining an effective security posture.
Thanks for watching. For more information, like, comment, and subscribe our channel.